engineering at Cornell Tech. His work has won a number of awards. I think Nikhil is the only person I know that's won awards across Informs, SIG Econ, as well as CSCW, which is an HCI conference. And he has a recent manifesto about participation that you may have to ask him more about. Please.
Cool. Thanks, everyone, for showing up on Thursday morning. I'm really excited to present sort of some work that really we've been working on. Is it possible to bring the mic down a little bit? Okay, thank you. Really excited to sort of talk about this work that really is about 3 years in the making, from sort of like reaching out to the collaborators initially to sort of finally having RCT results this past December. And sort of the work collectively is with Kenny, Emily, John, Ava, and Erica. Before I begin, I sort of just do want to acknowledge Emily in particular. She was really instrumental in this work. She was a PhD student at Cornell with John and Ava, and tragically passed away this last fall. And sort of she was really a pleasure to work with throughout this work. And like Aaron said earlier this week, sort of there's no great way to transition from this, so I won't try. Okay, so in this talk, I'm going to talk about sort of two projects, sort of on the same system, really intimately tied together. I'm happy to send a draft of the first one in particular. We have that ready. It's in revision. We haven't put it online yet. And then maybe in like a month or so, I'm happy to share a draft of the second one. And sort of the basic idea of the methodological challenge that we're going to tackle in the second project is sort of intimately tied to the theme of this workshop around prediction and interventions, in that you want to give recommendations to people in a capacity constraint setting where they're applying to schools or jobs or other things that are competitive, right? So you want to give recommendations. Those recommendations clearly need to depend on their probability of sort of being accepted to that opportunity, right? But as soon as you give recommendations, you're changing those probabilities for everyone, right? So now your predictions might be out of distribution, right? And so how do you give recommendations sort of in this setting where the sort of a key part of the recommendations are now being affected by your recommendations, right? So you don't want to give self-defeating recommendations of everyone to apply to and sort of tell everyone, hey, you have a high likelihood of getting into this thing, and then everyone applies, and then many of them are disappointed. And sort of stepping back, I think sort of I'm motivated a lot by this question, and like, why are information or recommendation tools by government less capable than recommenders for social media and products and everything else we interact with on a day-to-day basis, right? I don't want to say worse here, right? It's like you might think that these recommenders suck for many reasons, but they're clearly less capable, right? As sort of they're not real time, they're not interactive, they don't have a lot of capabilities that sort of these online recommenders do. And there's like the easy answers that like building software in government is hard, and sort of like maybe we just don't want this. But I think sort of there's also like important methodological challenges that are important but possible to tackle in sort of when it comes to building recommenders in high stakes contexts that are sort of different than the challenges you see in sort of low stakes contexts like products. And sort of with that, I want to sort of give a very quick advertisement, and sort of half my work is roughly computation, machine learning in government. The other half of my work is thinking about online marketplaces and recommenders in online marketplaces in particular. This is why sort of this question is always on my mind.
Does that include recommenders for government services or for political?
This talk. So this talk is a recommender in government services. But before that, I want to do a quick advertisement for a recommender in an online marketplace. So some of you might have heard about Blue Sky. It's sort of, I think, a great replacement for Twitter. What's cool about it is anyone can build and launch. It's completely open source, open API. Anyone can build and launch custom feeds. So anyone can be Elon Musk on sort of Blue Sky. All you have to have is people willing to use your thing. And so we built one, we built a feed, posts about research papers by people in your network. We launched it about like 9 months ago, sort of 1,000 daily active users, maybe after this talk, 1,020. And sort of, a lot of people seem to like it, and that sort of it helps them sort of sift through the noise and just see research papers and social media as opposed to other things. And if you like running RCTs, then maybe you like being the subject of an RCT. And so, help me write papers. Okay, great. Okay, but back to sort of not recommenders in social media, but sort of recommendation in this particular high-stakes context, which is New York City school matching. And so this first paper is a descriptive paper, sort of really setting out the problem, right? It's like, why do we need a recommender, or sort of why do we need to help people in applying to high schools in New York City? This was led by Kenny and Emily, and alongside John and Ava. Okay. So here's the context. So New York City, like many urban school districts really around the world, uses matching, centralized matching, to assign people to schools. And this is at every level, right? So for 3K, kindergarten, middle schools, and high schools. So every year, about 70,000 eighth graders match to over 800, one of over 800 high school programs. Historically, they could rank up to 12. As of 2024, they can rank as many as they want, and then they're matched through deferred acceptance. And sort of just descriptively, there's a lot of disparities in where students end up going, right? So the median Black or Hispanic student matched to a program with almost double the fraction of students who did not graduate high school, 43% higher fraction of those who did not enroll in college, 0.3 standard deviations, lower school impact, 0.6 standard deviations, lower school performance, right? So across a range of metrics, Black, Hispanic, and sort of lower income students are matching to programs with lower performance metrics. And people roughly talk about 3 potential sources of disparities and sort of that's causing this, right? So 2 that you could blame or sort of that you could consider are geography and admissions policies, right? So where are students living compared to these high-performing high school programs? And then New York City sort of stands out in the extent that it uses grades and historically test scores in order to match students to schools, not just like the 9 specialized high schools you might have heard of, like Bronx Science, but really like, 200 plus high schools, even beyond that, use things like grades and test scores to rank students, right? So you could blame sort of admissions policies for leading to these disparities. You could also consider application behavior, right? So controlling, and I'll make that clear in a little bit, for geography and admissions policies, perhaps disadvantaged students don't apply to high-performing high schools. And either sort of we could think about that reflects their true preferences, maybe that's what sort of some economists would say, or maybe it reflects like sort of a complex process. And I just want to emphasize that this is a complex process, right? So like I said, there's over 800 programs. I think it might be over 900 now. Programs, sort of for each of them, there's like a web page that sort of gives your academics, sort of like, what language courses they offer, what AP courses, arts, do they specialize, sort of what sports do they offer, because not all schools offer all sports. There's, New York City sort of calculates all these metrics for all of these schools. That's available through some web page. And then, they also do a bunch of survey data. And so you can look at, survey data on each school. Right? And one reason it's a complex process is because if you Google New York City high school admissions and you don't have an ad blocker, you're going to see a bunch of ads for consultancies to help you sort of navigate this process. Okay. And so let's maybe just set some ground facts on application behavior. Right? So the orange line is students eligible for free and reduced lunch. The blue line is students not eligible for free and reduced lunch. About 75% of 8th graders are eligible for free and reduced lunch in New York City. And so what you see in these plots is sort of everywhere in their rank lists, students eligible for free and reduced lunch apply to less competitive programs and also programs with lower graduation rates. Another thing I want to start pointing out is applications are sort of complex objects, right? It's not just what you apply to first, but sort of second, third, fourth, sort of, it's at least historically, at least a 12-dimensional sort of object and complex metrics in each of these things. And there's a large literature in New York City, both in understanding ranking and matching disparities, as well as sort of doing informational interventions. There's a lot of evidence, sort of survey, and otherwise that this is perhaps also, not just evidence of preferences, but also the result of a complex process, right? So people have done surveys on preferences and knowledge of programs, effects of policy changes that add or remove information. And there's, at this point, a robust literature outside of New York, especially Chile, and in college admissions. Okay, so what do we do in this first project? Sort of one of our goals was to really try to disentangle the role of geography in admissions policies, which sort of, especially if you think about what's in the political air, sort of admissions policies is the thing that sort of gets a lot of the attention. So we wanted to disentangle the role of geography and admissions policies from student behavior, right? So who is undermatching compared to where they could have gone, given geography and given admissions policies. And then the second thing is sort of really start thinking about not just sort of maybe where they applied to first, but really think about sort of this entire portfolio. And one reason you might care about the entire portfolio is sort of if the disparities are happening because I'm not applying to a competitive enough third or fourth program, then sort of intervening on the first program or trying to intervene on the first program might not be sufficient, right? It's sort of how complex your intervention needs to be depends on how complex sort of mistakes are. Or, not mistakes, but how complex behavior is. Okay, great. So then there's two challenges, at least, to doing this. First is you need some sort of estimate of match utilities or applicant preferences for each program. For the purpose of this talk, we're going to assume that program quality metrics somewhat capture preferences. We could have a 3-hour discussion on whether that's true. Happy to sort of especially talk about that offline, right? So I'm going to sort of show you a bunch of results that depend on selectivity or graduation rate or college enrollment rate, performance, impact, combination of these things. Sort of essentially everything points to the same story. The second thing we have to do is really sort of think about is, would the student have gotten in had they applied, right? Is like we need an understanding of this counterfactual, right? And this is hard. This is potentially hard in New York City. New York City has sort of every program has its own function on how they rank students. It depends on lottery number, grades, geography, sort of all sorts of things. And so we need to be able to sort of understand this counterfactual. What we benefit from in New York City is it turns out for like schools comprising of 80% of matches, we actually can almost perfectly calculate counterfactual admissions, right? So if you have access to the lottery number, you can build a simulator. It just takes a bunch of grad student sweat and labor. Is you can build a program simulator to just basically 95 plus 99% accuracy understand would a student have gotten in if they applied. Great. And so then what do we do? So we build that simulator. And then what I'm going to do is sort of, across a range of performance metrics, for the purpose of this talk, let's just say selectivity, so offer rate, like how competitive was the school they got into. And so in this case, lower would be better. I'm going to show you things like, so here's one bar chart. So for, let's say, Hispanic students, the sum of the bars is the match offer rate, which is where sort of on average, how competitive was the program that they actually got into. So for example, on average, Hispanic students attend a program that accepted 70% of its students. This dark blue bar is the sort of the most competitive program a student could have gotten to that was no further geographically than where they actually went, right? So this is our attempt to control for both admissions policies and geography.
How are you measuring how geographically far it is to get to?
Yeah, so in this paper, we only have access to student zip code. And so we're doing commute distance to zip code census tract. In the deployment paper, we're going to have access to census tracts. And so that's going to be much better.
Commute distance in what form?
What minutes?
Via any form of transit?
Yeah. I think not driving. So it's New York City, so commute distance by bus, subway, so on. And these are high schoolers in New York City, so that's pretty reasonable. Great. Right, and then this difference is what I'm going to call undermatching, right? Is the difference between where they went and where they could have gone without traveling further. And so, sort of, this is split by race or ethnicity. So the average Asian student went to school that accepted about 55% of its applicants and could have gone to a school that accepted about 35. And sort of the first thing to notice is the counterfactuals are fairly similar across group, right? So different students of different race or ethnicities could on average attend schools that are similarly competitive, that are no further away than where they actually attended. Right, so the disparities between where they actually went are sort of substantially larger than where they could have gone. We can also look at this geographically. So first, this is looking at sort of just that dark blue part in the previous plot is where did students end up going? And sort of where you see is students in downtown Manhattan where it's, most of this is quite expensive to live in, and Midtown Manhattan attend quite selective schools. Students in the Bronx less so, and right, so there's stark geographic patterns. And then you can also look at the undermatching, and sort of I think what's interesting is sort of controlling for where they could have gone is sort of illustrates some different patterns. So for example, for those of you who don't know Manhattan, this part of Manhattan, Riverdale, is quite wealthy. It's remote, but quite wealthy. And if you look at this plot, just where did they attend? It's they're attending reasonably, but not they're attending reasonably competitive programs, but not nearly as much as sort of downtown Manhattan, right? But if you look at the undermatching, they're attending about as competitive programs as you could attend without traveling much further. Right, so sort of especially when you compare them to their neighbors in the Bronx, sort of their lower income neighbors in the Bronx, Riverdale students are undermatching quite far less than sort of, right, so in some sense they're maximizing their geographic potential. Okay, the second thing to notice is so now what I'm showing you is a plot where the x-axis is a measure of how competitive the applicant is. So I'm splitting up applicants by the most competitive program they could have attended, right? And different lines are different groups by race and ethnicity. Same thing happens by income and so on. And then the thing to notice is almost all the disparities are happening amongst the most competitive applicants, right? So the students who the relatively disadvantaged students who sort of are most competitive for sort of these sort of competitive programs are the ones who are undermatching the most compared to their white and Asian peers. Okay. And so right, so these are just establishing some facts on who is undermatching compared to their geographic and admissions policy sort of potential. The second thing we wanted to understand in this descriptive paper is sort of where in the application are things happening, right? It's sort of how complex does an intervention have to be to potentially sort of help students apply, right? So for example, this is a student who was rejected from their first 3 programs and then accepted to their 4th program, right? And then the question is given a portfolio that looks like this, where do we even begin intervening, right? And sort of, I think what's important to know is sort of, just looking at an individual's characteristics, so like geography, income, race, and ethnicity, and so on, actually explains, there's huge patterns by those things, but it actually explains very little of their undermatching, sort of like across the population, right? 4% of the variance can be explained by individual characteristics.
Sorry if I missed this, but are most of the schools geographically concentrated, or they're pretty dispersed across?
They're reasonably dispersed, and and one way to see that is sort of if they weren't, then sort of you'd see much bigger differences in these blue bars.
Yeah, because I was going to mention there's some cultural segregation that happens in Manhattan a little bit as well.
Exactly.
Right? Okay.
Yeah, exactly. So so that was one of the things we really wanted to look at, is sort of like, right, is if these blue bars of where they could have gone without traveling further were like much larger, then it's just not worth doing an informational intervention.
I see. Okay.
Right?
Yeah.
And so it's important that these blue bars are reasonably close compared to sort of the informational part, sort of the behavioral part.
Yeah, that's helpful. Thank you.
Okay, right, so one thing that could be happening, and this was actually pointed out in prior work on informational, this is a great paper by Sarah Cahotis and others, on sort of just like trying to, surveying informational interventions in New York City and trying to understand when they work. And sort of what they pointed out and what we see in our data is sort of a reasonable chunk of disadvantaged students, whether by race or ethnicity or eligibility for free and reduced lunch, sort of are applying to essentially 100% offer rate programs first in their list, right? So they're applying to sort of programs with lower performance metrics that accept every student first in their list, right? And at that point, if that's true, then sort of the rest of your list doesn't matter because of how deferred acceptance works, right? As you get an offer from your first program, the rest of your list isn't even considered, right? So for those of you who don't know deferred acceptance, so you only get one offer, right? And you get offered to the highest program in your list that will accept you, right? So if your first program accepts everyone, it doesn't matter. The rest of your list doesn't matter, right? And this is sort of about 25% of black students eligible for free and reduced lunch are applying to 100% offer rate school first. Okay, and then we wanted to sort of quantify this by, okay, where would we need to intervene in each student's portfolio to sort of, okay, let's, paternalistically say offer rate is what we want to improve. Where would we need to intervene to improve competitiveness, right? And what we do is, so there's this really nice American Economics Review paper by Ali and Shore that sort of calculate the optimal sort of portfolio you would apply to in these correlated admission settings. We basically take their model, calculate the derivative of like, where according to their model would we most improve outcomes, and then apply it to our data. And then what you see is this model sort of outputs that the optimal recommendation you would make for essentially all, or not essentially all, for most Black Hispanic students, Black or Hispanic students, is apply to a much more competitive program first. The recommendations for white and Asian students are sort of more dispersed, right? I think the modal recommendation is still apply to a more competitive first program, but now the recommendations are far more dispersed. Okay. I'm gonna have we started 5 minutes now? Yeah. Okay, great. So, okay, so I spent way more longer than this than I wanted to. So 3 findings that are important. 1, application behavior is a leading cause for disparities. 2, most important highest amongst competitive applicants. 3, intervening on the top could help. Okay, so what did we actually do? After this descriptive paper is we ran an RCT sort of in collaboration with New York City Public Schools. This has sort of been an incredibly intense effort led by Erica Chang and then sort of a handful of folks at New York City Public Schools. And sort of, one of the reasons I have white hair now. Okay, right, and so I want to come back to this original question, why are information tools by government less capable than recommenders for media and products? And one reason is like building high stakes things just should be harder, right? Is like they're more important, you have to be more careful, you have to do things you might not care about and sort of for products and media. And this is my provocation that Angela mentioned. I'm happy to talk about it offline. Okay, right, so what was our intervention is exactly what you would expect from that prior work. Inform applicants from underserved middle schools about high-performing nearby high schools where they have a high chance of admissions, right? And what was key to this work is New York City, so this is led by, this is done not by our team, by two academics, Viola Cordini and Clemence Aido, who've been doing a lot of great work in this area. As of last year, New York City shows each student individualized admissions likelihood at each program in high, medium, low buckets, where they claim high means 99% chance of admissions, low means less than 1%, medium is everything between. And there's a reasonable spread. It's not like everything is median, right? It's like sort of many students have high chances at many high-performing programs. Okay, and sort of what's important to say is every student has access to this. And so essentially our control group students have access to this. This is going to be the control of our RCT. And so what did we do? We sent out emails that said, here, exactly what I said. Is sort of here are high schools nearby where you have a high chance of admissions. Okay, I have like 2 minutes left, so hurry up a bit. Okay, so what's the technical problem? It's what I started with, is each program is capacity constrained. And so nudging too many applicants changes application patterns, right? Too many nudges to the same program means these students aren't high likelihood of admissions anymore, right? And this is the real problem. So if we nudged everyone to all their high-performing programs and a reasonable number of them accepted our nudges, then sort of what you would get is the sort of, in many parts of the city, less than half actually get into the school that they sort of supposedly had 99% chance of getting into, right? So this is a huge communication and political problem, and just like, it's bad to tell people 99% when the reality is 50. And so our methods that sort of maybe I'll gloss over is how do you design these nudges to guarantee that still Y% of high likelihood students are still admitted, right? Even if X% of them follow them. I'll skip sort of how we did that, but it turns out you can do that. And if you're an OR person, sort of you might guess about how one would do that. And then you do an incredible amount of work to run an RCT, right? So use these offer likelihoods, sort of do focus groups, has to be approved all the way to the sort of the chancellor's office. You have to New York City has a whole lot of languages that people do things, so you have to translate everything to a bunch of languages. You have to sort of do all the data science that we said. We're now doing a follow-up survey. And so Superstar Erica sort of did all of this sort of this past year. Just an incredible amount of work. And so what happened? So we ran an extremely conservative, right? Like doing things, nudging students is a sensitive thing. You want to be as conservative as possible the first year. So we ran an extremely conservative RCT such that even if 40% of applicants followed our nudges, which would be the most successful RCT in the history of humankind, then still 95% of high likelihood applicants would be admitted to the programs, right? And then so what happened, sort of the control group, about 10% applied to programs that we would have nudged them to in a hypothetical nudge.
Quick question. So does the 40% affect your estimate of who has a likelihood of getting? Does that influence the likelihood?
Well, so yeah, so you have to make some assumption on behavior to then simulate out sort of acceptance rates, given
it's like
that.
An upper bound.
Yeah.
How likely?
Yeah, exactly. So
change other people's.
exactly. Yeah, right? So one person adopting a nudge changes other people's likelihoods. And so in the control group, about 10% applied to the program we hypothetically would have nudged them to. Even defining this is quite tricky. Happy to talk about that offline. In the treatment group, about 16% did, so sort of a relative increase of 60% for, let me just say, an extremely weak intervention, right? We sent emails, no one reads their emails. Yes, yeah. So we did, yeah. Everything is addressed to parents. Yeah. Great. So I'll end here. Happy to sort of talk about all of this offline. Really excited sort of about this direction. Sort of, I think there's a lot more to say about prediction and application settings and experiment design in these capacity sort of constrained settings. One thing we benefited from here that you basically never have in other settings is perfect simulations of counterfactuals, right? As we can simulate the match process, we know a lot, right? We can simulate effects of interventions in a way that you can't basically anywhere else, and that sort of gave us a lot of leverage. And yeah, and then I just want to end with this question. Hopefully other people think about this too. Hopefully other people help us build information tools that are sort of more capable in government than in media or for products.
Let's take one question as we transition.
So do you think, so with the analogy of like the recommender system and like recommender systems being way more sort of like personalized in the private sector, do you think that the recommender system in this case like should be way more capable? Like should it be like very sort of like personalized to like me as an applicant and like try to like figure out like my preferences specifically and so on?
Yeah, so so one thing we've sort of talked about for next year, with no commitments is sort of exactly, yes, like how do you do personalized to people's idiosyncratic preferences? Maybe you incorporate it in the platform they use to apply, and then you can ask a question or two of like, what do you value in schools, and then give more personalized nudges. I think you have to be careful about the congestion effect still. But yeah, I sort of, that's the vision in like 2 years. So I invite you again. Thank you.
Okay, great. Thank you for the great talk. Today we have someone whose theme about prediction and algorithms in public sector. So happy to introduce Mark Adenoff, our next speaker. Mark Adenoff is a historian of science, technology, and state. He's currently an assistant professor in the Department of History of Science at Harvard University.